Okay, here's the second part of 13.1. It was really long, so I separated it into two parts to make it a little easier. But notice that now you're graphing y equals negative 1/3 times 3 to the x plus 1 power minus 2. So your base is still a number that's bigger than 1 or greater than 1, so this is still growth. So this is a growth function, but it does have all of these extra translations around it. First thing we gotta do is we gotta figure out your base table. So your base of 3 to the x. So if you plug in negative 2 into x, you're gonna get 3 to the negative 2. And remember that 3 to the negative 2 is going to flip over because you can't have that negative exponent. So it's gonna be 1 over 3 to the second. I'm sorry you guys can see that well. So it'll be 1 over 9. 3 to the second gives you 9. So when you plug in negative 1, 3 to the negative 1, you have to flip it over. So 3 to the negative 1 flips over to 1 over 3 because it's 3 to the first. When you plug in 0, you get 3. I'm sorry, you get 1. Anything to the 0 power is 1. When you plug in 1, you get 3. And I'm not sure if you can see the pattern, but every time you move or you increase the x by 1, the y value is increasing by 3. So we can guess the next number should be 9. So this is your starting point. Now, if you want to start applying the translations to this, the first thing you have to apply is the negative 1/3. Before you do the x or the y, the h or the k, you have to make sure that you multiply that value by negative 1/3. So we're basically taking the values we had before, which we already have in the table, excuse me, and we're multiplying each value by 3. So if we take the first one and we multiply by 3, by negative 1/3, by the a value, we're gonna get negative 1 over 27. So your numbers are gonna be very small at the beginning, but again, they'll increase exponentially after that. When you plug in negative 1, you're gonna get, when you multiply by negative 1/3, your last value, you're gonna get negative 1 over 9. When you multiply negative 1/3 by 3, you're gonna get negative 1/3. When you multiply 3 by negative 1/3, you're going to get negative 1. And when you multiply 9 by negative 1/3, you're going to get negative 3. So all we've done is taken the 3 to the x that we had before, these values right here, from the first part of the table, and we've multiplied everything by 3. By negative 1/3, by the a value. There we go. Okay, so now our new values are going to come from here and here after we did the multiplication. So basically, this is your original x. This is your original y value that has already been multiplied by negative 1/3. So this one, we're not concerned with that anymore. We already got our negative 1/3 in, which means you already have a reflection over the x, and you've already included the 1/3 factor, which means that it's a compression by 1/3. So we have two translations already done, or two transformations done. So now we're going to include the new x value and the new y value. Because your h value was positive 1, it comes out as a negative. So you're subtracting 1 from every x. So this is basically x minus 1. You're going to take each of those x values and subtract 1. Because your k value is negative 2, you're going to take every last y value we got from that table we just finished, and you're going to take each y value and you're going to subtract 2. That is your k value. So as we fill in the new table, we're basically taking all the values of x and taking away negative 1. That's going to give us negative 3, negative 2, negative 1. You can see the pattern. Then will be 0 and then 1. Because your x values are increasing by 1, you have a pattern in the new x values when you subtract 1. For your new y values, you're taking all of the values here and you're subtracting 2. So it's going to be negative 1 over 27 minus 2. And we want to see that in decimal because we're going to graph it. So if you work that in decimal, it gives you negative 2, 0.3. And you're going to see that the numbers are going to go down from there. So slowly at first and then exponentially. So for the second one, you basically have negative 1 over 9 minus 2. That's going to give you negative 2.11. You have negative 1/3 minus 2. That's going to give you negative 2. 33. So notice they're getting deeper and deeper into the negative. If you plug in 0, you get -3. Sorry, if you subtract 2 from -1, you get -3. And if you subtract 2 from -3, you get -5. So these are the values that you're graphing. This is your final graph. We're not graphing the parent graph on this one and then graphing again for translations. We're just graphing the final values that we get on this one. So at -3, you're at -2.03. So you're about here. At -2, you're a little closer. You're at -2.11. At -1, you're at 2.33, so it's a little lower. And it might be a little off because it's really hard to graph points that are so close together. At 0, you're at -3. I'm gonna try to do the best I can. And at -1, sorry, at +1, you're at -5, so you're here. So basically, this is still a function that is a growth function, but because you have a negative a value, it has been flipped horizontally. So it looks like this. Instead of the one that starts above the x and goes up from there, it starts below the x and goes down from there because you flipped it over horizontally because of the a value that was 1/3. Because you have a compression factor of 1/3, it's farther away from the graph. So this part of the graph is farther away from the y-axis. And that's exactly what happens. So your k value being -2, that's what gives you your 8k, your horizontal asymptote. That graph is going to get closer and closer and closer to -2, but it's not going to cross -2. So then knowing that, we can talk about the features of the graph. So if we move over here, the domain is still going to be the same. The domain is always going to be all real numbers. So all values, for all values of x, x is between -infinity and +. For the range now, notice that this opens down and it doesn't reach -2. So it has to be all the values are less than -2. So you're going to have either y is between -2, and because it's going down, it's approaching -infinity. So it'll go to -infinity, or you can write it as all values of y that are less than -2 because it goes down. For your y-intercept, we have it here from the table is 0, -3. So there's no, we really don't need to, figure that out. It's already on the table. When x is 0, y is -3. And for your horizontal asymptote, it'll be the line that the graph gets closer and closer to or approaches, but it doesn't cross. So it's always your k value. If you look at your original function, that was -2, that is your horizontal asymptote. So it's y equals -2. So transformations, remember again, especially for the assignments, transformations, you're gonna start talk about the k first, then the age, and then your stretch of compression and your reflection. So you have a transformation from k of -2, that means 2 units down. So 2 units down. You had an h value of -1, so it was positive. Remember, when you take it out, it's the opposite, so it goes left. So it's, let's see how many, I forgot the number of units, 1. So 1 unit to the left. Then because your a value is 1/3, right, that's between 0 and 1, that's going to be a compression by 1/3. And the last part you're going to talk about is the negative. The fact that a is negative, it's a horizontal reflection. So remember to always start talking first about the k, then the h, and then everything else. So look at the equation from the back to the front. All right, so how are these functions or equations used in real life? Well, one really good application would be if your money is growing, if you invest money. So there's a growth factor that works for you if you open an account, for example, at a bank that gives you a percent increase or a percent investment every time that your money grows. So that is going to be, we're going to be using basically the equation a of t equals a times 1 plus r to the t power. And basically the t means time, The R means the rate at which the bank is giving you to grow your money. The 1 has to be there because this is growth. It has to be a number greater than 1. That's why you have 1 plus the rate. If it was decay, you would actually have a number between 0 and 1. So even though the equation doesn't change, the rate would be a number that's negative. And we'll see that in the next notes. But right now is 1 plus R, and that 1 plus R basically represents the B. That's your base. The A value in your equation used to be your stretch or completion. The A value here is your initial amount, the money you're putting into the bank. And the A of T represents the total amount after a certain amount of time. So basically, knowing that equation, you can figure out any of these problems that are given to you here, your word problems. So let's take a look at the first one so you see what I mean. So on this one right here, you invested $1,000 in a savings account at the end of the 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? So we've got the initial amount. This is your initial amount. This is your A value. You've got 5% annual interest. That's your rate. You have to change it into percent. It's in percent. You have to change it to decimal. So it's going to be 0.05 because you're going to move the decimal twice to the left. Make sure that your rate is in decimal and not percent. And the last thing you need is your T. So it'll be how much money is in the account after 6 years. This is your T variable. So if we look again at the equation, you have A of T equals A times 1 plus R to the T power, right? Replace all of those values with the values you have. So this is the amount you're gonna have after 6 years. You don't really do anything with that. That's just notation to mean that we're looking for the amount after 6 years. Your initial amount was $1,000. 1 plus R is gonna be 1 plus 0.05. When you add that, that's how you're gonna get your B that's higher than 1. That's why we need that 1 number in there. And then T is going to be 6 because it's after 6 years. You're going to calculate this first, then bring it to the power, and then multiply by 1,000. So we basically have A of 6 equals 1,000 times 1.05 to the 6th power. If I bring that to the 6th power, 1.05 to the 6th, and that answer, that calculation, I multiply by 1,000, I get a final amount of 1,340. So basically, your money grew $340 after 6 years of having that account in the bank at a 5% annual interest rate. So if we look at the second one, we're going to use exactly the same equation. So we want to know after 5 years on this one, how much money we have if we started with 500 and had an interest rate of 3.05%. So your A of T, you're looking after 5 years. So it's A of 5. And again, that's just notation. That's going to be your total at the end. Your A value is your initial amount. That was 500. Your 1 plus R, your R is 3.5, but remember you have to put it in as a decimal. So it's 1 plus, move the decimal twice to the left, you have 0.035, and the T power is going to be 5 because you want to know after 5 years how much money you're going to have. So this turns into basically, A of 5 is 500 times 1.035 to the 5th power. Remember, calculate the 5th power of 1.035 first, and then multiply by 500. So once you've done that, now you know that the amount after 5 years at a rate of 3.5%, starting out with $500, will give you 593.84. That's how you would use a growth exponential equation in something that's financial.